Hello everyone, I am Revathi. I am working as assistant professor in SNS College of Technology in Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic about CAP theorem. This concept explains why large-scale apps like Instagram, Netflix, Amazon, and Starbucks can sometimes go down or show inconsistent data. So far, we have learned about relational database, structured, ACID, complaint, and strongly consistent. But think about this, what happens when an application is used by millions of people across different continents at the same time? Have you ever opened a mobile app during peak hours and it said, please try again later, or refused to load anything? This is where CAP theorem becomes important. Let's see why. In 2019, Instagram faced a major global outage. Millions of users couldn't upload posts or even refresh their feed. What happened behind the scenes? Instagram's architecture prioritized consistency, meaning the data across all servers had to match perfectly. But when a network issue occurred, the system chose to stop availability rather than given inconsistent data. As a designer, how would you redesign Instagram to avoid such outages? Hold that thought, the CAP theorem answers this exactly. Imagine the frustration of users during an outage. People want apps that are always available, always fast, always correct. But at global scale, you cannot have all three simultaneously. There is hidden trade-off, and that trade-off is the heart of the CAP theorem. The CAP theorem is proposed by Eric Brewer, states as a distributed system can only guarantee two out of three properties. First one is consistency, and then second one is availability, and then third one is partition tolerance. Consistency. All nodes show the same data. Availability. The system always responds even in failures. Partition tolerance. The system works even when network connections fail. And here is the important truth. Network partitions will happen. So every distributed system must choose between consistency and availability. Let me relate to this real-time examples. Bank teller analogy. Two bank branches cannot sync due to a network issue. Should one branch allow withdrawals? If yes, availability. If no, consistency. Airline booking. If the seat availability system is down due to allow bookings, you might overbook. That is the trade-off. And then third one is e-commerce cart. Should users add items to their cart even when the inventory server is down? Most websites say yes. Availability matters more than perfect accuracy. Depending on the use case, companies choose differently. CA systems, almost impossible in distributed cloud setups. You cannot sacrifice partition tolerance. In CP system, prioritize correct data used by banking apps. MongoDB's default mode is CP. AP system prioritize availability over strict consistency used by social media and streaming platforms. Cassandra and DynamoDB follow AP. Let's look at a real example, Netflix. Netflix runs in 190 plus countries. It uses DynamoDB, which is an AP system. Why? Because Netflix prefers to show slightly stay data rather than slow a blank screen. This ensures you can always browse movies. Even if one region fails, data eventually syncs. This is how they avoid outages. Here is a quick question for you. If a health monitoring app must display patient vitals even during internet outages, what should it prioritize? Yes, availability. Because showing some reading is better than showing nothing at all. Let's wrap up. CAP theorem. You can only choose two out of consistency, availability, and partition tolerance. Network partitions are unavoidable, so systems must choose CP or AP. Banking chooses CP, and social media and streaming chooses AP. Understanding this helps you design reliable and scalable systems. Thank you.